Hey guys, welcome back to my channel. How's it going? In our previous video, we talked about the limitations of classical and frequency approaches to probability. Today, we're going to explore how mathematicians solve these problems by developing a rigorous axiomatic foundation for probability theory. Don't worry if this sounds intimidating, I will break it down in a way that makes sense. So let's start with something called a sample space. We already discussed that in our previous videos, and we labeled this sample space as S. This is a sample space, the space of all elementary events. 2, 3, 4, and so on. These elementary events are either the set itself or just the event itself. The elementary event itself is just the possible outcome itself. Now this S can be two types, discrete and non-discrete. We also covered this in our previous videos. When it is discrete, every subset represents an event. It is pretty straightforward. But when it is non-discrete, we can only work with a special subset, which is called measurable. These are our events. Now for each event A, in what we call our class of events C, we assign a real number P of A. So P of A is assigned to the A. It is what we call the probability of event A. Or sometimes it is also referred as a probability function. P of A gives us the probability of an event A happening, but, and this is crucial, it only works if three fundamental axioms are satisfied. Let me walk you through these axioms. They're actually quite intuitive when you think about them. So the axiom 1. This axiom 1 simply states that for any event A in our class C of measurable events, P of A has to be greater or equal to 0. This makes perfect sense, right? Because we can't just have negative probabilities. So the probability of any event A from our sample space is greater than or equal to 0 for any event A from our sample space. But I would rather say it is a set of outcomes. So let's say it belongs to our sample space. Or it can be even the sample space itself. It is more mathematically correct. Now let's take a look at the second axiom, axiom 2. Axiom 2 deals with certainty. If S is a sure event, meaning it's definitely going to happen, then P of S equals to 1. Remember how we talked about our probability being between 0 and 1? This is where it comes from. So we already covered in our previous video actually that the probability of our sample space equals to 1. And the axiom 3 is probably the most interesting one because it tells us how to handle multiple events that cannot happen at the same time. We call these events mutually exclusive. If we have events A1, A2, some kind of J, then in this case, the probability of any of them happening is just the sum of their individual probabilities. A simple case is when we have just two mutually exclusive events, A1 and A2. So we suppose to have 1A and A2 events, which make up our sample space. In this case, the probability of A1 or A2 equals probability A1 plus the probability of A2. And you can actually demonstrate this using the Euler diagrams. So we have the first set, A1, and you have the second set, A2. They do not intersect because they are mutually exclusive, and their intersection equals to 0 to the empty set. In other words. So let's take a look at the concrete example. Think about flipping a coin. Heads and tails are mutually exclusive, and the probability of getting either heads or tails is the sum of their individual probabilities. So the probability that we have head or tail equals the probability of getting the head plus the probability of getting the tail, which equals 1 over 2 plus 1 over 2. And this is actually the sample space itself because we only have two possible events. These three axioms form the foundation of modern probability theory. They give us a rigorous framework that solves the vagueness problems we discussed in our previous video. In our next video, we'll explore how these axioms lead us to some really interesting and useful properties of probability theory. Thank you for watching this video, and as always, if you have any questions, please leave them in the comment section below. I really hope you found this video helpful. If you would like to join our Discord community, you can find the link in the description, and you can also connect with me via LinkedIn just to stay updated on future content and mathematical discussions. We're engaging in mathematical or any other discussions. See you in the next episode. Thank you for watching. Take care.